Okay, so this is going to be a longer example than that previous one. It's not as straightforward. But so we've got the integral of x minus 3 over the square root of 4 minus x squared. So first thing here, if you're thinking through, okay, so I've got 3 integration formulas that are provided in this section. Which one looks like it might be relevant in this problem? Then you'll probably think of this formula. So the integral of 1 over the square root of a squared minus u squared du is equal to inverse sine of u over a plus c. The arc sine formula, integration formula, does not have the 1 over a in front of it. Just that's something to note. Okay, so yeah, that looks like it's relevant. I would use arc sine in this with this integration problem as opposed to arc secant because the constant term is in front. So that's the thing to watch for when you're distinguishing between should I use the arc sine integration formula or the arc secant integration formula. What you should focus on is not, I know the arc secant integration formula has this u in front of the square root. That's not actually what you should focus on when you're trying to determine the difference here. What you should focus on is under the radical. If you have the constant first, because remember a is a constant in all these integration formulas, u is your expression of x. So if you have the constant first, you should use the inverse sine integration formula. If you have the constant in the back, so expression of x minus a constant, then you should use the arc secant integration formula. Okay, so that's one thing. Also, though, we've got 2 terms in the numerator, so it's not exactly in that form. And what you can do in this scenario when you've got these 2 separate terms in the numerator is you can break this up into 2 separate integrals. So I can write this as x over the square root of 4 minus x squared minus 3 over the square root of 4 minus x squared. Close the parentheses. And then we can even integrate those separately. So now we can evaluate the integral of x over the square root of 4 minus x squared on its own, dx, minus, and then if we make this its own integral, then what I could also do is bump the 3 in front. 3 times 1 over the square root of 4 minus x squared. And now this integral right here is ready to go. We can go straight to this integration formula. This is where, so if this right here is a squared, then a is equal to 2. And if this right here is u squared, then u is equal to x, and du is just dx. So this is du right here. We don't have to make any adjustment for that. And so the antiderivative will be just, so we have this minus 3 in front. I'm going to write this all the way on the bottom because it's going to take a few more steps to solve this first part here. But with this second portion of the problem, you'll have the minus 3 in front and then inverse sine. So now I'm just following this integration formula of u over a. So in this case, that's x over 2 plus c. Okay, so we've got the second part of the problem done. Now I got to back up and handle the first part of the problem. Now this integral, you may have solved something like it in Calculus 1. We don't need to use any of the Cal 2 material to evaluate this integral, but this is the part of the problem that tends to give students more trouble. I'm solving this first part here because this one we're basically just applying a formula and we're done in the second part here. So in order to evaluate this first piece of the problem, we need to use a substitution. And that's going to be, we're going to substitute. Remember, we typically substitute for the inner function. So in this case, it's the 4 minus x squared. Since I'm using u in kind of a different way in this problem, I'm going to use a different letter. I know we usually use u for the substitutions. I'll use t. So let's say we're going to let t equal 4 minus x squared. Then remember, find your differential immediately. Then dt would be 0 minus 2x, so negative 2x dx. Okay. We're going to need to make an adjustment here. So in this integral, we have x dx. We want negative 2x dx. So I'm going to need to multiply by negative 2. I'm also going to need a little more room here. So I'm going to get rid of this, I suppose. Okay. And I'm going to kind of color code this. Draw a map. Okay. So this part of the problem turned into this part over here. Okay. We need to finish this part up. So I was saying that this integral here, let's use arrows instead, well, it's equal. Use the equal sign. How do I want to write this? Let's see. So the square root of 4 minus x squared, which this is going to become our t. And then we've got x dx. Maybe I'll use a different color for that. Here. So I'm sliding the x off on the end here because this is where I want to form that differential du, or dt in this case. dt is equal to negative 2x dx. So I'm sliding the x over here next to the dx in preparation for what I hope will become dt back here. So in order for this to be equal to dt, I need to multiply by negative 2. And again, if we just need to multiply by a constant, that's permitted as long as we multiply by the reciprocal out front. Because you can always take these constant multiples and bump them outside. If I did that, I'll have negative 2, well actually I'll have positive 2 over 2, which is 1. So these integrals are equal to one another when I insert the negative 2 here and the negative 1/2 out front. And so now this is equal to, I'll keep the color code going, negative 1/2 integral of 1 over the square root of t right here. So I'm going to write that as t to the negative 1/2 because it's 1 over the square root of t. So that's t to the negative 1/2 times dt. All of this whole negative 2x dx dissolves into just dt right there. So now that we've got it written completely in terms of t, we can just apply the power rule for antiderivatives, which means, let's see, so we've still got this negative 1/2 out front. You add 1 to the exponent here. So if we add 1 to negative 1/2, you're adding 2 over 2. That gives you positive 1 over 2. So this is t to the positive 1/2 over 1/2. Or go ahead and multiply by the reciprocal like I was doing in a previous video. Either way. But here, so if I'm multiplying by 1/2 here, I'm dividing by 1/2 here, then these are going to cancel. And so we have just negative square root of t. Because that's t to the 1/2 plus c. Okay, so finally, here let me circle this in red. So that'll become negative square root of t, which is 4 minus x squared. That's from right here. So this original problem is equal to all this. The first integral, here we broke it into 2 separate integrals. This first part here, we solved using this substitution, t equals 4 minus x squared. Worked through the whole substitution and then the power rule for antiderivatives and got this as an answer. And then this part here, integral of that, it's just a matter of move the 3 out front, apply this integration formula. And we got this answer here. And so overall, this entire integral here is equal to this at the bottom here. And that's your final answer.